Here you go. The game at a summer carnival costs $2 to play. The prize at this game is a stuffed animal valued at $10. The probability of winning the game is 27%. Calculate the expected value for the game from the player's perspective. Expected value should ring a bell, and it is. Probability of winning A times the gain for A, okay, plus probability of winning B, if there is B, times the gain you would receive for that game, and that keeps on going until you're done with prizes, and then it's probability of losing times loss. That's in general the formula for expected value. You should have that on your study sheet just in case. This is a 4-mark question for the page, right? So it's a lot of marks. Highlight the important stuff. It costs $2 to play. That's always important. It could be a contract. It could be anything, but it's the cost to participate, right? The prize is $10. Probability of winning is 27%. And it seems like there's only one prize. Okay? So here it is. Expected value. Probability of winning, there's only one prize, so our formula will be reduced to just that, right? 27%. How much would you be gaining? You would be winning a prize worth 10, but you always have to subtract the cost of playing, right? Minus probability of losing would be, to get that, and in a situation like this, it's just 1 minus 0.27, because both of them combined add up to 100%. Okay, so that's 73.73 times 2, because it's $2. That is your loss, because you haven't won anything, but you paid $2 to play. All right. And we'll calculate it. 0.27 times 8 minus 0.73 times 2. You could do this in one shot. If you have a decent calculator. I'm going to write down every step. You subtract, you get 0.7, and it's a dollar amount. It's always a dollar amount. So maybe we write down here expected value in dollars, right? Up on the original formula here, where my finger is. 70 cents. And I'll just make a note here. EV is greater than 0 when expected, and on average. Okay. If the EV is less than 0, loss expected. And obviously, if the expected value is 0, you will break even. Okay. Let's keep going. Justify whether the owner of the game should continue offering it at the carnival based on your answer in A. This is from the person playing this game. You expected a win, right? because it's greater than 0, it's positive. So from the owner's perspective, okay, the owner's perspective, right, you should not offer the game. Since the player is expected to win. And then we'll just say expected value is positive. You can say greater than 0 or positive, same thing. So write that down, and then we'll go on. All right, page 11. So I want to say something. Expected value, if it's there, it's going to be worth a lot of marks. So you got to be comfortable with that. So go back to the booklet and review it if you need to. I would have given you extra notes on that. An easy one here. 2 marks in total. State the probability of 13 out of 50 as a decimal and percent. This is an easy one, okay? As a decimal, we'll just go 13 divided by 50. It's 0.26. Not even a rounding concern there. And percent would just be times 100, right? It's 26%. But the symbol is very important. Okay, the units. 2 marks right there. Easy marks. So if you want to put this in your notes, 13 divided by 50. Sometimes they do that. Second last. 1 mark for the whole page. You know it's not going to be a whole lot of work. Group of 30 students were given 4 choices to choose their favorite color. These were the result. 9, 12, 6, 3. 9 and 12 is 21. 6 is 27. 3 is 30. So I'll just make a note. We're in probability 30 total. The teacher states, if I choose a student at random, there's a 25% probability that their favorite color is green. The teacher's claim is an example of theoretical probability. Justify the teacher's claim. And what we would have to say is that justify. Yeah, me see here what the best answer would be. The teacher states, if I choose a student at random, there's a 25% that their favorite color is green. 25 meaning 1 and 4, right? The teacher's claim is an example of theoretical probability. Justify the teacher's claim. So we have to justify the claim that the teacher made. Okay? The theoretical probability would be 1 and 4, or 25 or 25%. Prior to the survey. Okay. The experimental probability. Remember the difference between what should happen and what actually happened? The experimental probability would be, where's green? Green is 3 out of 30, which is 10%. Right? The experimental probability is 10%. Is the teacher is correct because it's a theoretical probability and it is correct. In theory, there's 1 in 4 chances, right? Okay. Oh, by the way, I just want to talk about something. Back to this. You could also make a claim that this distribution of color choice is not close to theoretical because the sample size is too small, right? Only 30 students, right? If the sample size, this is just another option, was increased, comma, the results in the survey would be close to the theoretical probability. Okay, so it's a little bit of a vague question, but again, show evidence that you took the course and that you understand the concept. So if you want to write that down, that's another option here. Vince, you're in, right? Because I just got that message that you couldn't join. Uranawi, that is. Okay, good. Keep going. Last question. 1 mark. Shouldn't be that much work involved. Choose a letter that best completes the statement. Sharon would like to borrow a specific book from the local library. The odds against the book being available are 1 to 99. So that means, that really means if it says against, it's not available to it being available. Not available, and it is available when it's worded like that. Probability of the book being available is U1, right? Probability of availability would be 99 over, and then you add up because that's the total, right? Adding up both sides of the odds, 99 over 100. So the best answer is D. Because then it says the odds against being available, that means that the first number is against it being available, and the second is of it being available. So the wording is important here. Okay? All right. So we did vehicle finance and probability here. Home finance, perhaps I'll do that tomorrow. Home finance, that is. So home finance goes way to the beginning. Page 1, and you do those, okay? And then I'll just give you the answers tomorrow, and then we'll start the green booklet as well. So hopefully we'll make it to all 3 before Friday's test. It is your best interest to you try it already. Don't wait for me, and then just correct it or add. You can write in them, you get to keep them, all right? That is it for